Okay, so here is the last question actually on the 2H paper in 2019 June. It's a vectors question. Often on the vectors questions, especially the particularly difficult ones, they'll have an easy part and then they'll use that to the later part. So 6 marks in total, 2 for the first part and 4 for the second. So let's look for now. It's always worth having a go, even if just the first one. But let's just structure this out. So they've not written the vectors on, but they've given us some. So C to E is A. C to D, sorry, is A. D to E is B. F to C is A minus B. Okay, so they've given us some vectors. Then it says express FE, this one, in terms of A and or B. So what do you have to do? So F to E, where we're travelling around, see this one's not too bad. So you're just literally adding up the 3 vectors that you've got. So it'd be A minus B plus A plus B. And you end up with FE equals, and then you've actually got 2A, and then the B's cancel, the minus B and a plus C. So FE is just 2A. Usually you use whatever you get from A in the second part. Let's have a look. So M is a midpoint of DE. So this is the M underneath my little arrow there. So that's midpoint. So that means that D to M is half B, and M to E is also half B. Then it says X the point Fm such that Fx, Xm, n to 1. Okay, so we haven't been given numbers. We've been told that F to X is n, and X to M is 1. So the ratio is that. Now, importantly with ratio is that when you think about this as parts, F to X as a fraction of F to M is actually going to be n out of n plus 1, because that's a total. Remember, normally if this was 2 and that was 1, it'd be total underneath, so 2 plus 1, which would be 3, and then 2 out of that. So that's a little heads up on this. I think this is going to be quite a difficult one here. And then X to M is just going to be 1 out of that same total. I'm just going to put that there as a side note, and we probably need that looking at this question. All right, let's grab our ruler. So C to E is a straight line, and X is on its way to that. Now, what we know about straight lines is that they are multiples. So for example, C to X will be a multiple of C to E, one way or another. So we know that, so that might help us. It should help us. CX, CE. So C to X and X to E and C to E, they're all going to be they're all going to be the same multiple because they are going to be parallel. It's a parallel line because it is a straight line. So work out the value of n. Okay, so I think the first thing we'll do is find C to E. If I find out what C to E is and then find out what C to X is, that might help us solve the n. So C to E, I mean, there are definitely going to be other ways to do this. And you'll go backwards on this vector, so it's minus A plus B plus 2A. So that is going to equal A plus B. That's nice and straightforward. So let's look at C to X. It's going to be a little bit harder because there's going to be portions involved. Equals. We know it's going to be along C to F again, so it's going to be minus A plus B, and then it's going to be plus the fraction of F to M. Now, F to M, let's do a little side note of what F to M is. just do this for a fraction of. So we've said what f to x is. It's a fraction n over n plus 1 of f to m. So it's a fraction basically of f to m. Now, if we just put over here f to m equals, and if you travel along, it's 2a minus half b. So then we can replace that into here. So let's rewrite that one out. Let's get our blue back. So minus a plus b plus n over n plus 1, and then 2a minus half b. Alright. So to now solve this, we need to expand this bracket here. So expanding the n and the n with a and b, just to get rid. We need to expand this really because we need to get as a multiple of CE, which is a plus b. So we need to separate the a and the b and factorise that out. Okay, to find the multiples. You see what I mean? So n over n plus 1 times 2a. Okay, so again, let's just leave this as it is at the moment, the first part. So this fraction times 2, so you end up with 2n over n plus 1 a times a. Hopefully you can see what's happened there. I've just times it by 2 and then the a has kind of come out separate. And this one is a negative, so it's minus n, and because it's a half, if you half something, you're actually dividing it by 2, and that means the denominator goes up by 2. So multiplication of 2, I should say. So 2 and then n plus 1 and then b. Okay, so now we've got a fraction with a in it, a fraction with b in it, and then we've got two just standard old minus a plus b. And so we need to factorise these so that they are in the format of a plus b with a multiple inside. So how to do this? We're dividing both by a. So let's look at a first. If we divide all of this by a, bring a out in front, we end up with 2n over n plus 1. And then minus 1. And then with b, minus 1 is, by the way, because it's minus a, it's dividing minus a by a, minus 1. Okay, and then b, we want a positive b. We want it exactly in this format basically, but with something in the bracket. So dividing both by b. So again, we just pick the fraction up. Oh, that's a minus, sorry, that fraction's a minus. And then b, so you'd be adding 1, like that. Now this is something else we need to think about, because we've got it in the format a plus b with this stuff in the middle here. If you think about multiples, we want it in the multiple, same multiple as a plus b. And if you take a bit of a side note and think, well, a plus b, a multiple of a plus b could be 2a plus 2b, oops, 3a plus 3b, etc. So they have to be the same number. So this and this, these here have to equal the same. And when we say about things equaling the same, we can turn them into an equation and literally make them equal the same. So if I've got one side, 2n over n plus 1 minus 1, and I need that to equal negative n over 2n plus 1 plus 1. And if we rearrange this so that the fractions are all on one side, and you're going to add it, and then the numbers on the other. This, sorry, I'm running out of space a little bit here. If you look at this one here, we want to add fractions, the denominator needs to be the same. So to do that, we can get times this first one by 2. So we end up with 4n. I'm just going to put it all just to save a little bit of space. And then it will be all over 2n plus 1. Hopefully you can see what's happened there. Equals 2. And then simplifying it, jumping a little bit maybe, 5n over this side. And then this side, if I times all of this by this fraction here by 2, on this side, 2 times here would be 4n, 2 times 2n is 4n, and 2 times, this will be 2, 2 times 2 is 4. Okay, so I know I've jumped a little bit there, hopefully you can see the jump, but it's just purely because I'm running out of space. And then minusing the n from both sides, 4n, sorry, n equals 4. So you get the ratio of n equals 4, and I say that's it. That is a lot, I know, to kind of know. I mean, you really have to understand that's grade 9, or certainly it's the last question. If you're going for grade 9s, you need to understand vectors because they use them so much at the end of the paper. Vectors and circle theorems, that you just need to go through as many examples like this. Just keep, even if you do the same questions 3 times, just so you know, understand how it should be laid out and everything. But hopefully that's helped break down that question a little bit. Is remembering that a straight line is always going to be a multiple. So c to x in this case and c to e will be a multiple of one another. And it makes it a straight line because they share the point x as well. So that's just another thing. But they have to be multiples if they are the same vector. So for example, this a and 2a, that's double that, and it's parallel. You can see that. So parallel lines and straight lines always have to have a multiple, and that's kind of where this comes in. Okay, so hopefully that's helped you out. I don't know if you did this paper last year or you're fearing vectors. You know that's quite a difficult example for you. Okay, any comments, please comment down below. Thank you.